Landing on Mars is not at all easy, and it is also for this reason that in previous missions, NASA focused only on the technical aspect of the descent, without worrying about documenting the various stages with movies or photographs. During the long years of preparation of the Perseverance mission, thanks to the improvement of digital filming systems, NASA's top management thought that the time had come to develop solutions to give emotions to the paying public, American taxpayers, as well as to have visual information on the different phases of the descent. And they did it by adapting cameras already available on the market. The only priority was that the filming system did not interfere in any way with the technical management of the rover landing. And the technicians really did their best, assembling in economy a video recording system called Entry Descent Landing, consisting of 5 consumer cameras connected to a computer based on Linux, which encoded the videos through the popular software FFmpeg. 2 cameras were mounted on the outer shell of the probe to film the opening of the parachute. A third was placed on the bottom of the rover, pointing downward to film the Martian surface. The fourth looks upward. Finally, the fifth was mounted on the sky crane to film the rover as it was lowered to the surface. And the result was well above any expectation. Despite some inconvenience due to high stress during landing, the cameras have allowed to obtain a video with an unprecedented definition, which gave moments of true emotion. The only weak point of the whole operation? The fact that we were only able to enjoy this spectacle deferred and days later, without the pathos that would have been there with the live broadcast, something that was obviously impossible to obtain because of the inevitable delay in receiving the signal due to the enormous distance between Earth and Mars, and also because the signals from the rover cannot be sent directly to Earth, but must first be saved locally, and then when the alignment conditions allow it, sent to the probe trace gas orbiter, which in turn will transmit them to Earth. In short, on our TV screens can never appear, not even in a distant future, the flashing writing live from Mars. There is the physical impossibility as well as the momentary technological impossibility. Okay, but what exactly do you see in this much vaunted video? Would it not be appropriate to make it a kind of review, so that even those who only occasionally deal with space exploration can understand the meaning of certain phrases, quite agitated? Obviously yes, and that's exactly what we're about to do. After a view of the control room of the Jet Propulsion Laboratory, understandably very quiet and rather concerned, the film continues with the sudden opening of the parachute, which, however tenuous the Martian atmosphere may be, will slow down the probe's speed in the first part of the descent. The NASA filmmaker shows us the scene in 2 versions, at real speed and slowed down. At that moment, Perseverance has been in the atmosphere for 4 minutes. It is at an altitude of about 11 kilometers and is still traveling at a speed of 1,500 kilometers per hour. From the video, we don't realize it, but the parachute is huge, 21.5 meters in diameter, and the cables that secure it to the descent module stretch almost 50 meters in length. The large umbrella opens quickly and immediately inflates without any wires getting tangled. The bright colors and patterns of the nylon dome are important because they will help technicians study its orientation, determining which areas inflate more or less. This film will be studied in depth over the next few years, also because of a curious peculiarity. The need to create a brightly painted parachute with an asymmetrical design simulated the imagination of Ian Clark, an engineer with a passion for cryptography who was assigned the task and who seized the opportunity to hide a message encoded in binary numbers in the shapes and colors of the parachute. Clark used the binary code to write "Dare Mighty Things," a NASA motto taken from a speech by Theodore Roosevelt, and included the GPS coordinates of the mission headquarters at the Jet Propulsion Laboratory in Pasadena. Clark revealed the existence of the Enigma in a televised conference organized the Monday following Perseverance landing, and to his great surprise, he had to take note of the fact that just after 6 hours, the solution had already been found. Some fans, in fact, immediately noticed that the orange and white color scheme on the parachute looked intentional, and they arrived at the result by using orange as the symbol for the digit 1 and white as the symbol for 0. It only took space fans a few hours to solve the puzzle, Clark said. Next time I'll have to be a little more creative. Sometimes even engineers can pull off a remarkable sense of humor, can't they? But okay, back to the description of the video. 20 seconds after the opening of the parachute, the heat shield, which until then had protected Perseverance from the heat generated by friction with the atmosphere, is ejected. And the camera, as if guided by a consummate filmmaker, frames it as it fades downward, smaller and farther away, destined to crash on the Martian soil. This is surely one of the most exciting and iconic sequences of the entire mission, realized by the video camera placed in the lower part of Perseverance, which is now at 9,000 meters of altitude and is descending at almost 600 kilometers per hour. Without the shelter offered by the heat shield, the rover is exposed for the first time to the Martian environment. Slower and slower by the parachute, Perseverance continues to descend, and at this point starts a long shot in which we see the Martian surface getting closer and closer, and where we can see more and more clearly the features of Jezero, the large crater almost 50 kilometers wide chosen as the point of arrival. In the meantime, the radar is activated to calculate the height, and another new technology comes into play: the terrain relative navigation, that allows the rover to compare what it sees with the camera with an onboard map to determine the optimal landing point. After another 90 seconds at a height of 2 kilometers, the parachute comes off, along with the back shell that still covered the top of the descent module. And in the video, the thing is clearly felt as the camera is shaken by the recoil, and immediately after the descent speed is almost halved, passing in 2 seconds from 320 to 170 kilometers per hour. They have in fact turned on the retro rockets mounted on the descent module. After another minute of controlled descent, the speed had dropped to a minimum of 0.8 meters per second. At this point, there are only 12 seconds and about 20 meters to touchdown, and it is time to start the sky crane maneuver. The descent module remains almost suspended in the air thanks to the thrust of the retro rockets, and gently lower the rover to the surface by means of 3 cables about 6 meters long. Meanwhile, the rover activates its mobility system, locking its legs and wheels in the landing position. The movie continues with the sudden opening of the parachute, which will serve to slow the speed of the probe in the first part of the descent. The video clearly shows how the whole operation takes place in a whirlwind of dust. In fact, the rover and the sky crane film each other while one is engaged in descending and the other in lowering. A splendid cinematographic double subjective. As soon as the rover detects that its wheels have touched the ground, it quickly cuts the cables connecting it to the sky crane, and this allows the latter, with a reversal of thrust of the engines, to fly away at a safe distance, free to crash away from Perseverance. A sequence from a science fiction movie perhaps surpassed, in terms of beauty and pathos, only by the historic takeoff of the lunar module during the Apollo 17 mission. The video then ends with the JPL control room exploding with enthusiasm for the perfect execution of the maneuver. The end. Practically, every frame offers new information about the process of landing on Mars. For instance, one of the springs used to eject the heat shield can be seen to have disconnected, though it didn't affect the process. All the footage has been, and no doubt will continue to be, scrutinized for other insights. In addition to these amazing landing videos, in the days following the landing, Perseverance transmitted back to Earth thousands of images taken by the cameras that are used by researchers to decide which path to follow for their robot during its explorations. By piecing together some of these images, mission managers have created a high-definition panoramic photograph that shows everything around Perseverance in the Jezero area. On either side of the panorama, the back and front of the rover are visible, with some distortion due to the lenses and the need to paste together images from different angles to each other. NASA has also made a navigable version of the new Martian panorama, which can be viewed via YouTube as a 360-degree video. Perseverance is also a good listener. It is in fact equipped with several microphones to record the impact on landing, and especially to listen to the noise of rocks, wind, sand devils, and wheels moving on the surface. These sounds that on Mars propagate differently for the different properties of the atmosphere will provide us humans an interactive experience, but above all will have a high scientific value. Those coming from the microphones on the SuperCam will provide, even at a distance, data on mass, composition, and hardness of the rock, useful to understand its origins. A microphone remained on even during the rover's descent to the Martian surface, but did not pick up any sound. while it was able to capture the audio below once it landed on Mars. Dave Grohl, chief engineer of Perseverance camera and microphone system, explained, "What you hear for the duration of about 10 seconds is an actual wind gust on the surface of Mars that was picked up by the microphone and